A 100 kilogram device is pulled up a plane inclined at 30 degrees to the horizontal with a force of 1000 Newton. If the coefficient of friction between the surfaces is 0.25, determine the A total force opposing the motion and B acceleration of the device. And we are given the acceleration due to gravity as 10 meters per second square. Now we are going to sketch this problem so that we can really understand what is happening here. So I'd like to create a sketch of the inclined plane. So let's call this the inclined plane. And then we are told that it is at an angle of 30 degrees to the horizontal. So this is 30 degrees to the horizontal. And we are told that there is a mass of 100 kilogram. A mass of 100 kilogram that is on the inclined plane. And we are told that there is a force used to pull it up the plane. And that force, I'm using P to show pull. The force of pulling up the plane is 1000 Newton. That is the force with which it is being pulled up the plane. Hope you are getting it now. Then now, we are going to look at the force that is down the plane. Now, the first force I want to write here is given by the force that is parallel to the plane. The force that is parallel down the plane. Don't forget, as you push this plane upward, because it is going up, then this thing wants to fall down the plane. So that force with which it wants to go down the plane as a result of this plane moving upward is what I'll call the force parallel to the plane. Let me use F subscript P. The force parallel down the plane. And then another force that will be opposing motion. Another force that, because this thing is moving in this direction, don't forget there's a force that opposes every motion on a surface. And what do we call that force? Frictional force. So I'll call this frictional force. So there are two forces down the plane. The frictional force that is opposing the motion. Why? Because the device is going upward. So friction always opposes motion. So when an object is moving in this direction, friction will oppose it and go in the opposite direction. So that's why I call this the frictional force, FF. And then as a result of the plane being slanted, so when you have a plane that is slanting like this, you have a force with which this object wants to go down the plane. So the force parallel to the plane that is downward is given by F subscript P. So this is the force on it. And then don't forget we have the reaction. We have the reaction on the plane. So that is another force that is acting on it. So now I'd like us to get these forces one after the other. Now let me start with the force that acts downward parallel to the plane. I'll call that FP. P means parallel to the plane. So the force that is acting downward parallel to the plane is given by mg sine theta. So this is the formula for the force down the plane, parallel to the plane. And then we can substitute values for this now as equal to the mass of the device is 100. So 100 multiplied by G, which is 10. G is given to us as 10. And then multiply by sine the angle which the plane is inclined to the horizontal, that is sine 30. So this will be equal to 100 multiplied by 10 is going to give us 1000, then times sine 30. Sine 30 is 0.5. So sine 30 is 0.5. So please don't forget what we are looking at in the question. So that is just a glance of the question again. And then don't forget we are given the coefficient of friction between the surface as 0.25. So let's move further so that we can move on with everything. Now the next thing for us to look at is to multiply all this value, and that will give us the force down the plane. So 1000 multiplied by 0.5 will give us 500 Newton. So the force parallel to the plane and acting down is 500 Newton. Then another force I want us to calculate down the plane is the force of friction. The force that is opposing the motion as the device wants to go up. So the force of friction. So the frictional force, we all know that general formula that says frictional force, I'll call it F subscript F, is equal to mu R. So the coefficient of friction multiplied by the reaction force. So this is the formula for friction. And then don't forget that this coefficient of friction can be written like that. Then this reaction, because it is an inclined plane, this reaction is not just mg. If it's a plane surface, reaction is given to us as mg. But for an inclined surface, the reaction is mg cos theta. This is for an inclined surface. The reaction is mg cos theta. So if we substitute values now, we are going to get the coefficient of friction is 0.25 as given to us in the question. And then multiply by the mass, which is 100. And then multiply by cos 30. And then working further, that will give us 0.25 multiplied by 100 is going to give us, oh sorry, I've not multiplied by 10. Don't forget it is the coefficient of friction multiplied by the mass multiplied by g before cos theta. So I miss out multiplying by 10. That is the value of g. So 100 multiplied by 10 is going to give us 1000. And then 1000 multiplied by 0.25, that will give us 250. Then multiply by the cosine of 30 is 0.866. So by the time we multiply these two values out, it is going to give us the frictional force F subscript F as equal to 216.5. 216.5. That is a frictional force. From there, we can now calculate the total force. Don't forget, the first question there says that we should calculate the total force that is opposing the motion. Hope you are seeing that. Calculate the total force opposing the motion. So if you look at the diagram now, the total force opposing the motion, we have the force parallel to the plane downward, and then we have the frictional force, and we have calculated the two. So we now have to add up the two values to give us the total force that is opposing the motion. And I'll call that F total. That is F subscript T. So F total, let me write it clearly. F total is equal to the force parallel down the plane, which is 500, and then plus the frictional force, which is 216.5. And then from there, we have the total force opposing motion as 716.5 Newton. So this is the total force that is opposing the motion. So we have our answer to question A. So I can now move on to question B. Don't forget, so far, what we have solved is question A part of the question. Then now, the second part of the question says we should calculate acceleration of the device. So the acceleration with which the device will move upward, that is what we are to calculate now. Now, for us to calculate that, I would like us to get the resultant force. I'll call this resultant force, I'll call it F subscript R. The resultant force is the force with which it is pulled. The force with which it is pulled minus the total force. Take note of that. The force with which the device is pulled up the inclined plane minus the total force opposing the motion. Let me show you from the diagram so that you get exactly what I'm trying to say here. If you look at the diagram, this is the force P with which it is pulled up the plane. And then we now have two forces that are opposing the motion, that are acting in the opposite direction of the motion. So from here, you agree that the resultant force now with which this device is moving is the force upward minus the forces downward. So the total forces downward are the one opposing motion, then the one upward is the one in the direction of motion. So the total force upward minus this total force downward will give us the resultant force with which the device is moving upward. So that is why I've written that as P, which is the force with which it is pulled upward, and that force is 1,000. The force with which it is pulled upward is 1,000 minus the total force that is opposing motion, and that is 716.5. So minus 716.5. And that will give us the resultant force with which the device moves upward as 283.5. So this is the resultant force with which it moves upward. Then now, don't forget that we have to calculate acceleration. And from Newton's second law of motion, when a body is in motion, the force with which it is moving is equal to the mass of the body multiplied by the acceleration. So our resultant force here is the force with which the object is moving up the plane. And that will be equal to mass times acceleration. Now, the mass is 100. And we have to find acceleration. So MA is 100A. And then this resultant force is 283.5. Then for us to get the value of A, we simply divide both sides by 100. So I can divide this by 100 and then also divide this by 100. So this cancels this. So we are left with A there. So the acceleration with which the object or the device moves will be this divided by 100, and that will give us 2.835 meter per second square. And this is the acceleration with which the device moves. And that gives us the final answer to the question. Hope you got it fully. Please don't forget to like, share, and join for more videos like this. Thank you for watching.